Hello, I'm David Brown at Berkeley Nucleonics, and this video series is going to walk you through all the features and functionalities of SpectraCore, our newly released software tool that matches up with the beautiful new RTSAs, the ICX400. Each feature will be defined in a small video so you can bounce around to just the features you need. Please reach out to us so we can answer any questions you have and get your hands on one of the new 40 GHz real-time spectrum analyzers. I'm Berkeley Nucleonics. Hey, David here. Today's topic is spurious rejection, a feature that cleans up some of the artifacts an analyzer can generate on its own. Let's dig in. Spurious rejection filters out some of the spurs the instrument itself introduces. Now, what does rejection actually do to different signal types? For the residual response of the instrument and for the harmonics its own system clock generates, the effect is barely noticeable. For the combined artifacts from partial images and mixing, the effect is much more visible. And a clean single tone signal isn't touched by it at all. Here's the one to watch for. Once rejection is active, modulated signals like FSK, APSK, and LFMCW can have their measured power pulled down and made inaccurate, which distorts the spectrum you're trying to observe. If that's happening, increase the sweep time. That preserves the complete signal spectrum even with rejection turned on. Let's see it in action on an ICX real-time analyzer inside SpectraCore. First, different spur types. Set resolution bandwidth to 50 kilohertz, video bandwidth to 0.01 times the resolution bandwidth, and stop frequency to 2 gigahertz. You'll notice the default rejection setting on M series units is enhanced. Click memory to save that trace, then switch rejection to bypass. Comparing the two traces, you can see some spurs disappear while the instrument's own residual response stays put. Now, feed in a clean 2 gigahertz tone at -10 decibel milliwatts and watch what rejection does to it. Set rejection to bypass, click update memory, then switch to enhanced. Comparing the traces, only the spur drops out, the tone itself is untouched. Finally, feed in a 2 gigahertz linear frequency modulated continuous wave, also at -10 decibel milliwatts, with resolution bandwidth at 100 kilohertz and video bandwidth equal to the resolution bandwidth. And with rejection on bypass, click update memory, then switch to enhanced, and you'll see the signal spectrum lose accuracy exactly as we described. Following the fix from earlier, increase the sweep time multiple to 50 times the minimum, and the complete spectrum comes back. Thanks for following along.